All right. All right. Um, Hello, everyone. My name is Matt Parker, and I'm the Energy Programs Coordinator at Walking Mountain Science Center. I'd like to thank all of our attendees as well as our sponsors. Today's sponsors are Holy Cross Energy, Walking Mountain Science Center, CORE, Garfield Clean Energy, the Colorado Energy Office, and Energy Smart Colorado. I'd like to begin with some housekeeping items. Everyone is muted upon entry. If you have any questions that you want to be answered by our panelists today, please direct them to the Q&A box. We will address questions at the end of our webinar today, and I am going to hand off to Mary Weiner of Holy Cross to introduce our speaker today.
Thanks, Matt. Hey, welcome everybody. Wow, there's almost 100 people. Who would have thought a year ago that we'd be able to do a heat pump workshop so successfully on Zoom? So thank you everybody for joining us. We think it's really exciting to see where heat pumps are going and how the technology has really improved. And I'm really thrilled to introduce our instructor today, David Peteroy. He comes all the way from Boulder, but you would never know it because we're on Zoom, right? So Pete, Dave has over 15 years of experience ranging from renewable energy, sustainability, and business. He founded, and I actually remember this from my years in Boulder, he founded the Blue Valley Energy, a ground source, or we call it geothermal, heat pump engineering, design, and installation company in Boulder. And Dave, I actually remember that when I lived in Boulder. So we're really thrilled to have you. Thank you for getting us more informed on this really important technology that's going to help us go electrified. So welcome everybody and take it away, Dave.
Thank you, Mary. Thank you, Matt and Nikki and all the sponsors. So these are today's topics. It's quite a lot of material. I got about 33 slides, roughly going to take somewhere around 35 to 40 minutes. It's going to be an overview with some key points in each area. Obviously, we can't dig into the areas in great detail, but hopefully you'll get some key points out of it. The pictures on the right are showing the evolution of heating technology, home heating technologies. And I would say right now we're right here between gas and propane furnaces and heat pumps. And there's cases now where the technology is good for a combination hybrid or all heat pumps or maybe the old technology. So let's talk about a little bit about the heat pumps. A lot of you are used to, a lot of folks still, I think, have in their heads that heat pumps don't work in Colorado. And I'm going to call those classic heat pumps. And in fact, classic heat pumps weren't designed to work in Colorado. They were designed to work above freezing. And this is a map on the left of old train map of where heat pumps work. And you see Colorado's out of that. And basically we were looking at, this is the climate zone map, climate zones 3 and 4. And that's typically where heat pumps were designed to work. But we're talking about a different category now, a technology evolution. And let me see, I get my screen to advance for some reason. Everything worked good before. Oh, here we go. Okay. So around early part of the century, around 2005, I'm going to say a birth of a technology evolution, these cold climate heat pumps. Initially there was efforts to start defrosting, work on the defrosting, because obviously they weren't going to work in cold climates without the ability to handle frost. There was another big impetus that really started things rolling, and that was unsurprising increase in natural gas prices. This is a graph of residential gas prices in Colorado from 1985 all the way up to 2020. And it was very tight, small fluctuations. And all of a sudden, there was a little bit of deregulation, some other factors. Katrina eventually came into play. But the sudden rise in gas prices prompted some folks, especially in the Northeast where energy costs are higher than in Colorado, and in the Midwest to start looking in a more serious way. There was more R&D funding. And then around 2010, 2012, we started to get the mini split systems in from Japan for cold climate applications. And then about 2010 to 2015, the Northeast Energy Efficiency Partner, or NEEP partnership, really started to take a hard look at this and drive research, adoption, marketing, application in New England. And in fact, there was even some Alaskan field trials, not related to NEEP, but up in Alaska. There's been work in Europe. So this technology grouping has been out and operating in harsh climates for the last 5 to 7 years. I'm going to talk in a few minutes about some field trials in New England and Minnesota. Let's talk about I'm just going to touch briefly on what actually was done inside the heat pumps to some extent to help the technology move forward. I'm sure some of you with the manufacturers have a lot more in-depth knowledge of this, but we want to touch on a few things. There's the inverter-driven scroll compressors. So scroll compressor has been around a while, but a good compressor technology. Inverter-driven is they're able to continuously modulate the output of the compressor to match the needs, the heating and cooling loads needs. Also, there was some working on hot gas bypass and other strategies to actually keep the compressor warm during extreme cold operations. The alloys and walls of the heat exchangers, this is a constant evolutionary process. Thinner walls, more advanced alloys. Fan blade design, more efficient fans, not only in the outdoor units, but in indoor units. And one of the last things is with computer controls and modulation, you can match the capacity of the outdoor unit with the indoor unit and ECM fans. So suddenly you've got this ability for the whole system to only output what is needed. And that efficiency gain really helped drive some of the economics. This is a big, this shows the evolution of the efficiency. And basically, I'm going from 2012 to 2020, and there's been a dramatic improvement. Around 2012, if you went and looked for efficient heat pump technology in the market, you have about an HSPF of around 8.2. And throughout the years, they keep improving all the technologies, and now the best are around 13. All the manufacturers have, top manufacturers have one or two product lines of cold climate heat pumps in the series. 10 is really the floor now. So between 10 and 11 and 11 and a half. So this improvement represents a 34% up to 59% uptick in efficiency. And obviously that's what helps make them more cost effective and economical to run in cold climate zones. The second important effect of the development was the capacity. And right now, again, I have a scale on the bottom. It goes from negative 10 to 70. This is the heating load of a home. This is just a line of a 5-ton home heating load. And what I'm looking at here is the trend in the capacity of the heat pumps, basically below about 30 degrees. So you'll notice that above this is where classic heat pumps. So there's been an evolution of the capacity. This is sort of how it used to be down below, and the capacity to heat in this critical zone from 30 to 10 has increased dramatically and almost matching the load. In fact, some of the more advanced, and in particular the mini splits, their capacity can hold up all the way through into the negatives. I put in a 4-ton heat pump. I'll talk a little bit about later on a 5-ton home, because often in retrofits, you're a little bit constrained on the size. Let's talk about two really interesting studies in cold climates. I mean, it's nice to have these stuff on paper and everyone talking about how great they run. Nothing like testing them in the field, making sure they really do what they say they do. A big study was up in Vermont. Notice Burlington, 10 degrees, average winter low temperature, very close to Eagle, which is about 8. Nice thing about this one is they looked at 77 mini splits over 2 winters. Smaller units, but same technology. And down to about 14 degrees F, the COP held really close to the nameplate. These heat pumps, most of them were operated into the coldest outdoor temperatures. The interesting thing was the field HSPF was about 88% of the nameplate HSPF. And then the next study, I'll show you a little bit about that. That really is a measurement of the defrosting impacts on efficiency. This study is another one in a very cold region, central to northern Minnesota. Notice that -1, so plenty cold, even matching some of the Colorado's coldest areas. This was a bit different. This was another 2-winter study, but 6 sites, mix of ducted and mini split, mostly ducted, and they set them up in a dual fuel capacity with propane, some all electric, and they had a changeover temperature. The interesting thing is they really measured the operational characteristics of the heat pumps on 15-minute intervals. And this chart shows the details. The blue is when the heat pump was operating. The yellow is in defrost mode. Notice some occurring at 32 degrees, some coming in around in the 20s, and the green was the backup, whatever the secondary source was. And they found that basically the defrost operation, and probably I would say even things like wind chill, ended up reducing it by about 8%. So between these 2 studies in the field, you notice there is some environmental impacts on the efficiency. Not great, but you need to take that into account. Now, talking about this new category of heat pumps, cold climate heat pumps, how is it defined? Who's defining it? Well, NEEP is really taking the lead on this, and in fact, they have their own database of cold climate heat pumps that you can go online, search by manufacturer and what your criteria are. So I would suggest you go take a look at that. Some of their criteria is it has to be an AHRI match system. Obviously, that's critical. If you don't have matching indoor and outdoor units, you can lose as much as 15 or 20% efficiency. A compressor must be 3 speeds or continuously variable. Almost all of them in the cold climate regime are continuously variable. It holds up a nice COP at low temperatures. The HSPF ducted is greater than 9, non-ducted greater than 10. This is trailing a little bit behind where the manufacturers are. I mean, most of them are greater than 10, as I mentioned before, and a lot of the utilities in Colorado for their rebates are looking at 10 and above. This is a map of Colorado climate zones, and I wanted to bring this out. I know there's people on from all over the state. I'm really focusing a lot on talking about the really cold regions, but everything I say basically applies to the milder regions. It's just a little bit easier for the heat pumps to do that, and the economics might be slightly better. The one thing here is this climate zones, for those of you are from the east, represents from Maine all the way to Virginia. And if you look around the globe, we're very unique in how cold and our elevations and our population. There's not a lot of that combination. Even if you go over to Europe, Switzerland, Austria, they're only at 5,000 feet. And one thing here, you have these dots. I wanted to take a more careful look at this. I felt this map has been out a while, and I wanted to make sure the granularity made sense. So I really looked at the 5 months, the 5 heating months from November to March, and analyzed that a little bit more, because the climate zones include the whole year. And really with cold climate heat pumps, you're talking about the 5 coldest months on design. And so my dots really, the southern mountains are as extreme as the northern mountains. For those of you who live in Colorado and ski all over, you know that. The southeast is actually a little bit milder, certain areas, in the southwest climate zone 5. So just a little update on that map. This might be one of the most important slides in the deck, because I'm not sure everyone is as familiar with our heating distribution over a year. Everyone feels like we're really cold in the winter, but that's not really where we use a lot of our heat. And so on the bottom axis is outdoor temperature, and on the vertical axis is the % of annual heating energy use. I did not include cooling. cooling still is rather small, even though things are getting hotter. So on the right side, the orange, basically about 1/3 of our heating energy, and this is Eagle, is used in mild above freezing, classic heat pumps. This is the big area, 49% from 15 to 35 degrees, where the cold climate heat pumps really shine. And if you look at if you take the yellow and the orange and you combine it, that's over 40%, that's over 80% of the annual heating load of homes in almost all of Colorado. So the cold climate heat pumps are well adapted to handle this. Now in the very cold situations, a lot of the heat pumps can't handle way down in here, especially the mini splits. But generally you're going to pair this, be it with electrical strip or another hybrid type system. But in general, the heat pump's going to be able to handle most of the load heating throughout the year. I want to talk a little bit here about, so the next section I was going to touch on is cost and emissions analysis. And we're going to look at all the different kind of combinations, propane, we got some hybrid, heat pump, electric strip, et cetera. I think the thing to think about is, as we go through this, is really, in this day and age, there's 4 homeowner concerns. The initial costs, the annual heating costs. With financing so low, I think many homeowners don't even realize how effective you can actually upgrade to higher cost units and finance them. And the annual costs with the financing and the heating costs from 1 to 7 years is one thing, and 8 years plus is another, and emissions. So in the past, folks would just think, what's the initial cost? Is it low? Does it heat my house? Great, I'll buy it. I think now a lot of people think about at least what's the initial cost? How much is it going to cost me to heat every year? But surprisingly now, this third line, I think more people are going to be thinking about that. If there's a lot of good financing and emissions, depending on where you are in Colorado, what section of the state, big groups are going to be really caring about that. This is some of the inputs. I don't want to, it's in the appendix. I got a lot of this stuff in the appendix, and you'll get the slide deck. I don't want to spend a lot of time. I've got a 5-ton house, changeover at 15. I did higher at natural gas. I'll explain why later. 95% furnace, D rate 22, pricing as current as I could actually get on these. And I did a cost adjustment for defrost in the field, and I used the Right Suite Universal on these. And this is just to show you an output. A lot of you guys have used Right Suite or something else. You put the model in, you've got your loads, you put in the different options, electric furnace, propane furnace, strip, heat pump with strip, heat pump with propane, you get your dollars out. That's a pretty simple thing. That really doesn't get to where we need to be. This gets to where we need to be. And so I'm looking at the 4 aspects of the homeowner, and this takes into account a couple of them. The top, so across the top, I'm comparing everything against the propane furnace. One is, then the second column is propane furnace with the heat pump. The third one is heat pump electric strip. In fact, the third and the fourth, I'll explain in a minute why I have that the same. And the last is electric furnace or baseboard, fully electric system. So the annual heating cost for this home, 5-ton home, up in Eagle, you'd look at the $4,350 for the propane furnace, and this is the savings if you go with the heat pump hybrid model, heat pump with strip model, and then electric furnace is a lot more. So let's look at what happens after the rebates and the initial cost, the propane furnace, and bidding and costing varies tremendously. I realize that. I'm trying to pick what might be realistic numbers here. 8,000. I've got a furnace and a heat pump at 23. I've got 2 versions for the heat pump because I know there's wildly varying bids and pricing depending on the situation. 15 and 20,000. And after the rebates, which are quite generous up in Holy Cross and a lot of the tri-state areas, and Excel's changing theirs to some extent. And other rebates, you've got 8,000, close to 20, close to 11, 15, and put in 6. This is electric furnace. I mean, if it's baseboard, it's really nothing. It's and then this is the ROI. So you've got about 10%, and then depends on what the cost is for the initial cost of the heat pump. A $15,000, 14, a $20,000, it's about 10%. But let's say that you've got customers who, they don't have the cash. They need to finance it. So I've looked at a couple different financing strategies. This first one is if they finance the entire cost of the system, and I try to be reasonable. I looked at a 7 years and I took 5%, which is, you don't have to have an 800 credit score to get that. I think it's pretty realistic. A lot of folks can get that. And this would be the cash outlay. And you'll notice the annual cost in this case, $5,700, the heat pump and the furnace, $5,800, a little bit more, a lot more capital outlay at the beginning. 46, you're saving a bit on the 2 heat pump with electric strip, depending on the initial investment cost. And obviously the furnace is higher. But let's look at a second one. And I've done the difference between the 8,000 and these. And what we're looking at here is financing the same thing, 7 years, 5%. It's pretty much the same. Basically, everything's lower. So this is kind of the situation in years 1 to 7, about half, a little under half of the lifespan of the equipment. After that, obviously, it reverts up to these costs. So tremendous savings after 7 years. And we want to look at gas now. And obviously, everybody knows gas is a very inexpensive way to heat your home. And in fact, so why did I do I've got a furnace here. I've got a heat pump with a gas hybrid, and I've got gas with AC. And I did a 45-degree changeover because the trade-off is, even though you're going to spend a lot more money, I'm trying to make it so, okay, I get a heat pump with a gas furnace and try to keep the operating cost close to the same. Gas furnace is doing most of the job, 80% of the job, low cost. The heat pump's doing it when it's really mild, down to the mid 40s. And it's obviously a lot bigger outlay. However, if you're comparing it in a lot of the state where essentially AC is essential, people consider all the regions 4, all the eastern part of the state, western slope. Basically, the heat pump versus the AC is almost really a no-brainer in a way with the rebates. I mean, even if it costs a couple thousand more to install the heat pump, with many of the rebates around the state, you're ending up with a lower first cost, or even, and what the heat pump gains the homeowner is control over. It's a risk mitigation, depending on how gas prices go up, how electricity prices go up. They can vary the changeover point. The other advantage, which I'll talk about in the next slide, is for that percentage of your potential customer base that really cares about emissions. They have a tool now, which is significant to take care of that. So let's actually look at this. So what this is annual CO2 for this house, and various different options. And I want to show this compare. This is a car. This is sort of the average car, 22 miles a gallon, 13,000 miles a year. So it's around 11,100 pounds of CO2 per year. Now, many people are out buying cars to greatly reduce this, and they're heating their homes with equipment that's on the same order of magnitude, and they won't have to put out as much money to take care of this. So this is present day 2020 annual, where this is Holy Cross is 44% CO2 reduction from the baseline, and you can see all electric, and you got propane. Heat pump with electric, just a touch less, because we're using electric strip at a 15-degree changeover. Got gas furnace. I got heat pump with propane, and heat pump with gas at a 45-degree changeover. So if it was lower, this would be lower, but you would be paying a lot more. here's the big change, and it's coming. This is by 2030. Now, Holy Cross announced they're going to try to go with 100% reduction. Tri-State and Excel have 80% reductions. So I've used their 80% reduction by 2030 versus 44 now versus their baseline. And you can see massive changes. In fact, all electric way down. Propane's going to just barely reduce a little bit. Gas is going to go down some. The heat pump scenarios go way down. I mean, no surprise. This is sort of where the trend is. Now, this kind of analysis takes less than 5 minutes. And I think that there is a certain group of customers, I'll talk about that a little bit later, that, would really weigh heavily on their kind of decision making. A couple interesting things. There's a program in the appendix. There's a slide on it, Pure. Holy Cross is a great program for people who want to try to mitigate even further. And I don't have time to go into it here, but obviously if you pair this with on-site solar, there's some real strong synergies going on, at least in this arena. Let's talk a little bit about sizing factors. And this is not, in 35 minutes, this is not a course on how to design and size. I'm really trying to hit on some of the key points that you need to be thinking about and that you can focus on as you go to the next level. So obviously you got to look at your load, your utility incentives and the requirements. Is it what else is on site? What makes sense? What are the options? And what's the existing duct system? So the sizing example here, Holy Cross, the heat pump has to be used 80% of the time in a hybrid setup. And that's around a low 20 changeover temperature. So pairing it with a gas furnace or a propane furnace. You're obviously going to want to use manual J to determine the heating load profile. I mean, this is important with heat pumps to get the sizing right. You've got to make sure it has the capacity to do it. You don't want to way oversize it. I'm suggesting that up in the cold high country, you look at the balance point in a range of 15 to 23 degrees. That's, if you go back to that slide where I showed the heating load, that's about 80%, and that's a really nice area where there's sort of a natural changeover. And we'll look at ducting, because ducting kind of influences where that's going to be. You got to derate for altitude, a paired system, and the capacity curve. Look at it in here. And a little caveat here, there's this category of cold climate heat pumps. They do all have better capacity. They do all work with defrost, but there is variation in their load capabilities. So you really want to look at those curves. The last thing is the existing duct system large enough to really handle a CFMs required, and I'll talk about that next. So the heat pumps, as probably most of you know, but maybe not all, they're outputting temperatures in the mid-90s to mid-100s, whereas furnace is much higher. In fact, this is a common customer complaint when they don't understand heat pumps, is it says it feels like the air coming out is cold. And that's an educational issue. The heat pumps need a lot higher CFM per ton than gas furnaces to deliver the BTU. In new homes, you design rough guidance, 30% larger duct size. But here we have two inherent advantages helping the situation. The current heating system is obviously going to have to be designed for the extreme temperatures. And so thus the duct system, and often in homes in the 70s, 80s, even probably in the 90s, there's the furnace and the ducts might be a little bit oversized above a real tight load calculation. If there's an existing AC unit, it's just a little guidance. Obviously, it doesn't substitute for rigorous analysis, but the ducting is obviously adequate for that size and probably a ton larger. This was the diagram I put up earlier with the load capacity of a 5-ton. And just to give you a quick, at 25 degrees is basically 3 ton. So the heat pump would need 1350 CFM at -5. need 5.5 tons. This is a furnace, so you know you'd have 1100 CFM. The whole point of this is that your needs are going to be pretty much close in this strategy. Now, when we're going out and talking about new technologies, and I know this is nothing new, but indoor air quality is becoming a bigger thing. I'm sure a lot of folks are putting in heat recovery ventilators, tight homes, fresh air. A couple of trends that I think are hitting us. No surprise, wildfires. It's happening, forcing people to keep their homes shut for a lot longer, shut-ins, which makes it difficult. I mean, you have this, you can't open the windows. The other thing that surprised me was everyone, I think, feels that things are getting hotter. And this is since 1872. On the average, Denver sees 31 degrees each year with high temperature at 90. And there's 3 in the 2000s, or the days are in the 70s, and consecutive days in the 20s. So the bottom, what I'm just concerned or thinking about is people are keeping their homes shut up. And if you get heat pumps, it's gonna help to improve a little bit of indoor air quality. You're not gonna have any possibilities of any other kinds of emission for your heating. So that's another thought and advantage of the heat pumps. The ducting, I'm calling them essential ducting improvements. With lower temperature, you need to make sure there's good airflow for comfort. The supply return geometry at the air handler unit or the furnace, if you're coupling with that. Often the returns in the older homes, it's simple to add a couple of returns that they're choked off. And the wireless thermostats, I'm sure you've been putting them in a lot, but that's great because you're getting a better thermostat location. And educating the customers that they shouldn't do dramatic setbacks. That's becoming some feedback from a lot of people, that the customers will call up and say, "Oh, my heat pump's been working. It's uncomfortable." Well, the problem is they're not letting it just gently and steady keep the house warm. A couple beneficial things. I mean, obviously, you probably try to do some simple zoning. Makes a big difference. Ceiling insulation if you have access to the ducts. Mini splits have been out there a little bit longer, and they're more prevalent. A couple slides on mini splits. A lot of you on this call are far more experienced experts at the mini splits, but there's some out there, architects, et cetera. I want to touch on a few things. Obviously, there's great design options: ceiling, walls, floor. Here's one area I'm not sure. Now, maybe people give me feedback. My sense is these ones up in the ceiling, these little duct units, you can duct either slim fit or a little bit thicker where you can duct a couple of rooms. I think these could potentially be utilized more because there's some real nice advantages in terms of effectiveness and cost of the system. Applications, everybody, electric baseboard. Obviously, if someone's got electric baseboard and they want to invest some money and get that heating cost down, especially if you got an attic, you could put units in the attic. And what I was talking about before is in the second floor, usually with one of those little ducted systems, you could basically get 2 rooms that are next to each other off of 1 unit. So rather than putting in 4 indoor handlers into a second floor, you might be able to get away with 2 or 3. And new additions, advantages, the ducts, but you don't have to upsize the whole HVAC system. I think for new homes, ductless also give this nice flexibility from design, from contractors to really think about the second floor as a separate system in the first, and does it sometimes make more cost sense to look at just doing some mini splits in the second floor. You eliminate a lot of ducting vertical, a lot of ducting in the attic, which used to always be a big variable cost with more risk than most of the other stuff. And it helps make some more room, and you don't have to worry about vertical. So there's some advantages there. Really quick, with the design, you have to make sure the indoor unit, you got to derate the indoor unit too. You've got to make sure it's got enough. Obviously, you're going to have, with the mini splits, it's going to be the sole source. You're going to design to extreme temp. You don't really want to oversize things, unnecessary cost, and both indoor and outdoor. And you want to make sure the zones are reasonably balanced. My suggestion is, whatever manufacturers you're working with, they have good, simple, sophisticated software to optimize, the indoor units and the distribution to get the best efficiency. You're not overcycling, or you're finding the best COP to run. This is another area, just a quick mention about air to water source heat pumps. Mainly we're talking about for radiant or in-floor. A lot of people are asking about, is there another way besides the boiler, or can I combine the boiler with the heat pump system to get a little more efficient system? These have been in Canada for 10 years, and there's quite a few of them up there. Right now, there's a few products available in the U.S. Right now, and in the appendix, you can see I've got a table. They're listed. There's some great contacts in Colorado that'll work with you on design, et cetera. There's some really good products globally that haven't come to the U.S. yet. It's a great option for new construction because, you can design the system together. It's a little bit tricky on boiler failure. I guess if you're working with one of the designers and you can have a good sense of what it's going to cost, what it's going to take, you could potentially give two-step offerings and say, well, here's a boiler, and in a few weeks we can come in and add on a heat pump. This is what will gain you. Or if you're out doing boiler repairs, you realize that it's coming to its end. You could work with a designer and come up with the system. Obviously, this is going to be something really for people who want to reduce their emissions and have a little more flexibility. One thing, if everyone can, the consumers still don't get the idea of a high temp baseboard, and these just are not going to work for that. There's obviously some real modern radiators that run at low temp. So up in Colorado and any snow country, the difference between a AC and putting this in is, the location. You guys deal with it up here every day. You don't want the call the person didn't shovel out their heat pump. So a few things just touching on for a lot of you, these will just be reminders, maybe something extra. Other folks who are on the line are not contractors, something to be aware of. So you got to think about noise, especially like in the Eastern Plains, Western Slope. These things are going to be running in the milder months, spring and fall. If somebody's on their patio, they might not want to have this running next to their patio or their open bedroom window. So you got to be aware of that. Wall mounts are great, lower right, great setup. You got to have it mounted solid. You might have a little vibration, so you might not want to have the person's headboard right in the other side of it if possible. I did mention about defrosting and how that has a penalty on the units. If you can get it in the south or the southeast, the sun's going to obviously help that a little bit. It's going to help with the condensate, make sure that line stays free. You want to try to avoid the north, and you do want to block the west wind. I mean, there is a wind chill effect. I'm not sure anyone's quantified that in a real careful study, but people have mentioned it. I know it's like I would have never, as a contractor, wanted to be out building walls, but certainly landscapers would be happy to build a small little wall, or some homeowners. Obviously, and this is sort of my thoughts, is if you look online, a lot of people say, or talk to folks, 18 inches should be good, but I'm going to put it at the height of the maximum average snow depth of the maximum month, which Vail is 31 inches. Our rifle's only 4. I might do 12. So I'm going to pay attention to that. The snow and ice shelters are really nice. And in fact, if you email me, I've looked up, there's a couple companies in Canada that actually manufacture these. So you don't have to sort of do your own deal. You just buy it. And I'm sure more of the manufacturers are making them available. Effective drain pan heater with some kind of, emergency signal, warning signal. protect the condensate line. And this is interesting, you know, I was lucky enough to talk to someone the other day, and they're like, yeah, just drain this condensate to a safe location, you know, don't have it go sidewalk or driveway. You're not creating an ice skating rink for your clients. Everybody knows about line set, minimize, use insulation. I think the only point here is if this line set's not really super insulated at 10 degrees, that's different than at 25. So, you know, the impact is a lot greater. So, you know, it's all about business decision. I know that the industry, HVAC industry right now is very busy. It's in a way, even despite COVID, it's sort of pushing along, and in Colorado, busy. And, you know, so the question is really, is it time to invest in the training and to incorporate these? And just a few thoughts on that. You know, the technology's there. And surprisingly, there's groups, you know, roughly 60% of customers in Holy Cross territory are really concerned about emissions. I mean, it's just becoming a thing for a certain subgroup of consumers. In Colorado, depending on where you are, could be 25%, could be 75%. I mean, I was thinking about it, it's almost like when people go out and buy cars, some people buy, you know, very fast sports cars, some people buy big, strong trucks, some people buy gas sippers, you know, and each group's like, why would I buy that one? But to them, it's really important. So this is becoming, you know, a big point. There's a lot of momentum, you know, the utilities, you saw all the utilities are offering, you know, strong goals for DSM, et cetera, and that's just not going to go away. You know, harder to sell, but more revenue. If you're not already into this, if you're not already in tight with the manufacturer, I'd pick one and really know their product line. I've mentioned this before, add the CO2 cost benefit to your quotes, easy to do. There's some good software. You got to do some training on the training page. I know Tri-State's focusing on some of the Right Suite Mobile, really nice app. You know, you can get an edge. Customers like rebates and choices. So a warning about selecting a product line, and you know, the internet and is starting to impact the HVAC industry. It has been for a long time. There's a lot of relabeling of equipment. I mean, some mega manufacturers, you wouldn't even know who they are. And people are just relabeling some of it and setting up and selling them online. You know, to me, and that product might be actually a really good product. It'd be the same line that's making Train, Carrier, all the good ones, same stuff. But the problem is who stands behind the warranty. You know, this is 15 to 20 years. If they're pushing the warranty down, and you got to do some research, they could be pushing the warranty down to the distributors. You know, are the distributors putting money aside to handle the warranty? They have equipment, et cetera. So that's just a word of caution. Let me summarize. A lot of writing on this. This is going to be available. You can read through it. You know, hopefully, you know, talked about a new category, heat pumps designed to work in our climates. There's a lot of different applications listed here. I'll point out that, you know, for new homes in the milder climate zones, you know, a heat pump's really good option. It's a good option in various strategies. I can't say it enough. Design and install properly and price for profit. I know the customers are tough. They really don't want to pay, but from experience, selling ground source heat pump systems, which were expensive for 10 years, you know, you just have to, you can't underbid the extra effort. You should must meet the homeowner expectations. The example is, you know, I took 10% off for a real field operation. You know, that's trying to not overpromise things. You know, there's a lot of trends. There's a lot of drive and support for this. Look on the training page. The other thing that's happening is there's a big push consumer education. This is happening. All the groups are going out. You know, I have 4 talks next month, various consumer categories, lots of people out giving talks about this. And really it's to teach the consumers where the technology is, and now they have choices. Like we're at this very exciting, interesting transition. You've got lots of options, so at least consider them all. So the appendix, there's technical training. I refer to that. I can't emphasize enough. I didn't look up all the manufacturers' trainings, but they all have great trainings if you get with them. I think a lot of them are doing it online. Local incentives, lots of local contacts programs, some financing outside of the bank, which I think if you get in with, they can really expedite that. The Pure program, and I've listed some of the heat pump series. And also a key thing is refrigerants always changing. There's some updated information about what the EPA is going to do. Wrong way. And well, thank you for your time and attention. This is some of the groups. My email's down here. So if later after the talk or something you want to get into the nitty gritty of any of this or have some stuff, let me know. We are going to be taking questions. Thank you.
Thank you, Dave.
Thank you so much, Dave. That was such a great presentation. I know it's a lot of information to put into a short amount of time. And just as you said, we are going to go ahead and open it up to questions. The first one that I want to address is it's kind of a two-part question. So is there a bypass for mini split users when one occupant calls for warmth and another calls for cooling? So can the heat pump do both?
I believe so. Yes. And Mitsubishi, maybe the Mitsubishi guys can chime in on the chat to confirm that.
Yeah, so I was just going to say, Sean, I know Sean's here from Mitsubishi. So if you want to answer, I know there's the variable refrigerant flow can do that, do both heating and cooling. But Sean, if you want to chat in, if the Mitsubishi mini splits can do that. Or if Kurt's on.
Meantime, we can do part 2 of the question.
Actually, that was both parts. Just making sure that, you know, can it do both at one time?
So one room wants to heat and one room and another room wants to cool, which we see that typically in a large home where, you know, the south facing gets a lot of sun and then the north facing, they have the heat on.
Right.
So
that is correct.
So that's what the question's asking.
Yeah, I believe so.
So we can follow up with that question again later and move on
Sure.
to the next
We'll
one.
confirm that one.
Yeah. All right. So our next question is a scroll compressor a linear element rather than on off?
A linear rather than on off, you said?
Mm-hmm.
Yes.
Yes. I mean, it's a, well, I'm not sure. I understand the crux of the question. It's a continuous, so it's not just on off. I mean, I guess I'm not sure I understand the question as a on off versus linear. And it would make sense. I'm not sure. I mean, I think I need a little more clarification. If you can email me that question.
All right. So if that person could go ahead and email us or
A little more
put in-
detail. I need a little more detail to answer that one.
And Dave will
Okay.
have his contact information.
It's
at
on the
end,
bottom.
too.
It's on the screen.
Okay, yeah, we will try and get more
I
clarification.
need more detail on that question.
Yeah, we'll get more clarification on that, and in our follow-up, we'll definitely address that one. All right, so our next question is, how does altitude affect heat pumps output? Is there a D-rate factor?
Yes, yeah, by altitude there is a D rate factor, and it's around 20%. It varies a little bit. So Vale is, I believe, 22%. And if you get down to Rifle, it's around 16%. So yes, there's a derate factor.
All right. And then I do want to address the heating and warmth question again, because it looks like Sean Lamons from Mitsubishi has responded. Almost no systems do both at one time. That is a commercial product option, and they need separate compressors for residential simultaneous cooling and heating. All right, so we'll move on to our next question. When does the COP become equal to 1.0 or electric resistance with the new energy efficient heat pumps, and what outside temperature?
You notice the cold climate heat pump specification required 1.75 at 5 degrees. So even below zero, all the ones that are designed below zero are still going to be slightly above 1. So, I don't know the exact. I mean, it probably would be like -20 or something. It depends on the specific piece of equipment. But basically, for almost the entire temperature range with cold climates, it's above 1. It's more than electrical. COP is above 1.
So Matt, can I interrupt real quickly? Can you
please.
Can you unmute Sean Lamons? He's our expert from Mitsubishi, and I think it'd be easier. He can help Dave with some of these more technical questions, since he knows the Mitsubishi in and out so well. So could you unmute him, and then we can see if he wants to add anything.
Yes, I just did that. So Sean, if you'd like to have any input, please do.
Hey, how you doing? Can you hear me okay?
Yep.
Cool. Yeah, so this has been a fantastic presentation. Thank you so much, Dave. Really, really great information for everybody. Yeah, just a clarification on the simultaneous. Obviously, they switch between cooling and heating, and almost every single system out there has to be in heating mode or in cooling mode. It'd be kind of like running your air conditioner and your furnace at the same time. While it is possible in some of the commercial systems, there are very, very few residential grade systems out there that do that. And I did cut out a little bit there, so that if there was a second question on that, maybe on the COPs, is that right? COPs at low temperatures?
Yeah, what's the COPs at below zero?
Yeah, so looking across manufacturers, you're going to want to look at the performance data, and you're going to want to look at the input versus the output, right? Capacity versus energy input, and you can do the math. Sometimes you'll see charts or curves showing the COPs listed, but generally you're going to see COPs ranging in the 3s and 4s and 5s at moderate temperatures, and down into that 1.5, 1.8, 2.0 range, down in those really sub-zero, -10, -13 temperatures.
Yeah, I wanted to ask you, Sean, for clarification. Though they don't simultaneously heat and cool, the systems can switch back and forth fairly quickly, correct? Like if there was a room that had a heating and a cooling, the system, whatever called first, would satisfy that, and then it could actually switch modes to the other one, right?
That's correct. Yeah,
and it's fast.
If you've got what's called a multi-zone system, well, I'll start with a single zone. A single zone will move back and forth very quickly, as you talked about. You can even kind of make that change standing there looking at it, and it does take a few minutes for the system to think about what it wants to do and then act upon it. And they are kind of slow to respond by default, by design, because of the efficiency. But if you've got a multi-zone system, one caveat for everybody to know is that generally the systems are last call condition. So if you've got, let's say, 5 indoor units connected to one outdoor unit. And one of those remaining indoor units is still in a cooling mode. Let's say you're going into the fall and it's been warm upstairs, and one of those units is still in cooling mode, but the other 4 want to go to heating mode. Heating is going to wait until that cooling mode has been switched off. So it's kind of last call condition for those indoor units. So it's just again, it's an educational opportunity for people to understand that this is a slightly different system, and learning how to work with different routines and patterns.
And back to the D rating. So I did find, like to give you ideas, Eagle might be around 22%, and then Parachute 17, and Vail up near 27. So there is variation. That's basically 8,000, 7,000, 6,000 feet. So it's a big factor. You got another question, Matt?
So we are at our 5 o'clock time limit, and understand some people may need to leave, but I think, Dave, you're able to stick on for a few minutes and answer some questions. Is that right?
Yeah, sure.
I'll let you take it away, Matt or Mary, with some questions.
All right. Yeah. So it looks like we got some clarification from one of our other questions about the COP being equal to 1.0 or electric resistance. Oh, wow, it just disappeared. All right, so we'll move.
So Matt,
on.
can you see him, or do you want me to help? So one is, so Dave, one is on the refrigerants. Do you have that slide in the appendix on the changes coming up to the refrigerants?
Yeah, right here. So it's the last slide. It's the last slide in the deck. Yes.
Okay, so that one's just a good one to reference for anybody, because you're right, refrigerants are contributing to greenhouse gas emissions, and there are big changes coming. And so this will be in the slide deck. So thanks for that question.
Yeah.
If I may contribute to that one a little bit, refrigerants is absolutely a leading consideration for this industry. And so for anybody that's out there that's doing designs or asking for designs to be done, consider the total ounces, pounds and ounces of refrigerant in the system. And, that should be a consideration for design. If you've got a system that, sure, it'll meet, your heating load at -20, but it's going to have twice the refrigerant in the system, depending on the motivation of the installer, the buyer, the utility, etc. That's a big impact on overall global warming potential. So just something to think about. You can get the work done for a lot less refrigerant with good design.
Perfect. Thanks, Sean. So Marty from CORE is wondering, he sees plenty of analysis of systems with backup heating, and I have to admit, most cold climate heat pumps I've seen installed will have an electric resistant backup. Do you have any performance data on heat pump only in cold climates, Dave? Like if they use 100% of the heat pump?
I wouldn't recommend that, because what that would mean is, for example, if you're designing Eagle, you would have to design the design temp like -6 to -10. So that means you would design the heat pump and the curves fall for it, but you basically have to design the heat pump very large to get the capacity there. Whereas if you put a small amount of strip in, you put strip heat in to assist in that, your heat pump's sizing is much better matched to your overall needs. And really, even though you think that the electric is gonna run a lot and contribute a lot to your energy bill, I'll show you. Give you the example here. Let me go back to the top of the deck. This is why this is important. Now the mini split's a different story, because basically you're putting the one system in and doing. But so for example, here, if I run the heat pump down to zero, I've got almost 90%, 95% on my heating. I'm just using this for a little bit. And what you don't want to do is if you go up to the sizing curve, you don't want to have to size the heat pump. So it's alone, it's way up here. You're going to way oversize. So as much as it's counterintuitive, a small amount of backup, be it electrical, be it propane, be it gas, it's not, it's actually not a bad thing. And in fact, the fact that it'll allow it to match the heating needs over the rest of the curve for the rest of the year, run more efficiently, will make up for that little bit.
Okay, great. Thank you.
That's one other approach with the multi-compressor system as well. Rather than doing a very large heat pump, air source heat pump, or doing a multi heating strategy. Let's say you have a 2-story house, you could have the heat pump on the first floor have its own compressor, the heat pump on the second floor have its own compressor. These one-to-one compressors are lower cost than the multi-zone or the much larger systems. So you might be a wash on cost, might be fairly even on cost, purchase cost. And then the bottom unit can heat the house overall with the buoyant air that rises up in the swing seasons. So you're efficient in your swing season. And then your top unit can do some cooling in the summer without running the bottom unit, et cetera. So you can get there with kind of this staged approach, but obviously costs and complexity are part of the consideration as well. But yeah, it's a great slide, Dave. Thanks for sharing that one. I actually looking forward to the slide deck or the PDF on this one. I'm going to enjoy that one.
I want to add that the design strategies for the mini splits is somewhat different than the whole house strategy. So you really want to be aware of that, because you have the ducting and especially retrofits constraints, et cetera. So there are really two different sort of thinking strategies that you need.
All right. Well, thank you for answering that question. Definitely a lot of information there. Our next one is 10.5 HSPF. In the financial examples that you provided seem higher than what is out there generally. So what make and model was the reference for this unit?
Here, it's the American, I can send it to you. It's the American standard, and there's the model number. Typically at 10.5, you're going to be looking at the top couple product lines. And if you look in the appendix slide, I've got a list of a lot of the manufacturers. It's typically their top 1 or 2 unit lines, product lines. So that's what I was saying when I showed the slide overall of where the HSPF, and really that's kind of cold climate. These high efficiency, high HSPF. These are the products they've put the best engineering in, and they're designed to do this. They're not gonna. And the other thing is if you try to put in HSPFs that are lower, then the economics aren't as good either. So really is these sort of higher end products.
And the NEEP equipment list is what you use, Mary, correct? And that'll be listed in there.
I just do. So if you want a rebate with Holy Cross for the cold climate, the heating seasonal performance factor, HSPF, has to be 10 or greater. And that is coming from that Northeast Energy Program that did a bunch of research on heat pumps, what entails a cold climate one.
If you go in the appendix and look under resources, NEEP. If you go into NEEP and search in NEEP, and you can get their cold climate heat pump list, and you can do searches on it.
The thing to keep in mind is that that list doesn't get as updated because the heat pump technology is rapidly changing, and there's more heat pumps coming on the market. So just be aware that they update it as much as they can, but it's not always up to date, as Mitsubishi has discovered. So
Yes.
All right, so our next question, how do you handle fresh air ventilation when using ductless mini splits? I assume you need a separate system, yes or no?
Yeah, normally you put in a little HRV systems, and it depends. There's several strategies. Like the second floor, when I had a contracting company, we would have a small HRV up in the attic, and we might duct it to a couple. You can either duct it to one central place and pull from another, or you could even duct it to a couple of rooms. Lately, one of the things I think for some houses, you can actually, and it's not HRV, but you can actually put in small, fresh air fans in the attic with the ability to duct into rooms. And what you do is, it's a little different strategy. It's basically like a sophisticated bathroom fan, but now basically you turn that on and you can crack the windows and basically pull a little fresh air in from all the rooms. That's kind of an interesting, lower cost, low noise, nice solution. It's not heat recovery ventilation, but it is a ventilation strategy.
All right. So another question, can different cassettes hooked up to the same compressor run different temps or fan speeds? For example, keep running a high fan speed in the cold room and maybe a lower temp on fan speed in the warmer room. I think we touched on this a little bit, but yeah, if you could give a little more clarification.
I assume they're asking about mini splits. Yeah, you can put different units for different rooms, and and you have the controls in each room. So each there's a lot of flexibility in how you run them and set them and run them. Yes.
All right. Have there been any studies on which method of supplemental heating is most efficient? For example, using an electric duct heater for supplemental heat when outdoor temp falls too far below normal operating range, or putting the heat pump in a doghouse and using, quote unquote, doghouse, and using a gas-fired or electric space heater to raise the temp of the doghouse to normal operating temps?
That's a really interesting question. The short answer is no. I haven't seen any studies for that. But that's really something interesting to think about, because I didn't bring it up here, but I did. All these extreme weather conditions. If you have a place that you can put the heat pump that's protected, a shed or somewhere like a dog house that you can make sure you have proper airflow in a house, then all of a sudden you take away these factors of all this harsh climate. It really helps a lot. Would it make more sense to heat? Probably not, because you're doing a couple levels of energy transfer. If you think about it, if you're putting a gas heater in the doghouse, so you're heating the air, that's one level of energy transfer. Then the heat pump does a second level of energy transfer. And just my intuition's telling me that it's just not as efficient, and really it would be a complicated thing to do. And realize we're still talking about not a large portion of the annual energy use. So you really do want to think about the sort of keep it simple rule to some extent. But putting it out in a protected area, I'm all for that. If you have a Doghouse is I'm just questioning whether it would make sense to like heat the doghouse air when it's really cold.
Yeah.
My gut's telling me that's not worth it. It's just sort of the physics of energy transfer.
David, I'll
And
chime in on
so-
that one.
Oh,
So,
go ahead.
Well, there is a quoted quote doghouse strategy from Mitsubishi City Multi Products for large commercial. So putting the outdoor units into a space, and rather than putting a cold climate system in, they're putting they're sizing for cooling because it's commercial. They're putting it in a space, and then they're putting in supplemental heat within that space with, managed dampers and all that stuff to hold on to the airflow, et cetera. It's pretty complex. So picking up on your point of simple is better, David, is typically the way to go. And yes, inline duct heaters or accessories, extra heating accessories or backup systems just within the building shell is typically the simplest, easiest, relatively efficient way to go. And I'll just throw one last piece in there too. There are some of those studies that are out there. They'll say that, well, you might see a 3%, and this is just an example from a study I read, 3% extra energy from electric resistance during the heating season with a 5% premium, if you will, on the heating cost for the year because of that additional, cost of electricity and no COP of 1 for that electric resistance. But if you size it properly and it's in a small percentage of usage of time, it's a simple, straightforward, serviceable, etc.
The installation and how well that's done overwhelms those kind of nuances. The sizing, the length of the line sets, the insulation of the line sets, protecting the unit from wind, trying to get it the defrost right, the condensation right, all of those, making sure that you have a great match system. That can affect the performance 20 to 25%. And that's one of the reasons that the utilities you'll see in the training, Excel, Tri-State, everyone's working very hard on the quality of the install, and that's really what it's about. And the customers have to realize they need to pay for these better systems. And I'll be touching on that in the consumer talks next month if anyone's listening, emphasizing consumers that this is important. You get what you pay for, and you're paying for something for 15 to 20 years. So this is not something you're going to keep for 2 years and throw away.
All right. Well, thank you all very much for this. We do have some more questions that I think we will go ahead and address via email. And Mary, would you like to say anything else?
No, I just want to really thank everybody for coming. It's great to have so much interest in this. We are going to do more trainings. We have a lot, whatever utility service area you're in, look for the rebates. Contractors, please help us promote this. We are really wanting to do smart electrification now. And we're so thankful for all of you that joined us. And Sean, since you're on the line, there's just a couple of questions on the electric strip heat. And can you explain that a little bit, how that works?
Sure. I was just looking at Scott's question about ductless and ducted. Yeah. The short answer is I happen to know our line. I don't know other lines very well at all, but our lines, our equipment does have, our ductless equipment does have the capability to call for backup heat when it sees that it needs it. It's a control mechanism. It's a wiring strategy to a backup system. So you could literally have your stage 1 heat be a ductless system in your living room, let's say, but then you wanted to turn on your floors later on. There's a way to manage that. You could actually have it wired just to a pellet stove or a baseboard heater or some other kind of heat source. It has the logic built in. It has the wiring capabilities. I can't speak to other manufacturers, but it's there. There's some of these nuances that's coming out in the technology across the industry that You know, it's really going to take a little extra thought and time to design a system that's going to meet your needs.
And I just want to add on to that. And that's why I wanted to emphasize, I think, you know, if you want to get into this, that you should really pick a manufacturer that you're comfortable with and work with them, because, you know, there's great system, Mitsubishi, Daikin, all of them have great technology, but knowing the details and the nuances to get it right, I think that's important.
I think that's a great statement to end on, that you get what you pay for, right? That never goes away, right? So it comes with heat pumps and we cannot stress, all of us local partners cannot stress the need that you got to find a contractor that can install these correctly, because you will not be happy with a heat pump and then they'll get a bad name. So we're happy. Send us your quotes. We're happy to help. We're available for you. So our contact information is on the screen now. Thank you all for joining us. Thank you, Dave. Yay. Thank you, Dave. You can't hear us clapping. And Matt and Nikki and all the other partners that went together. We hope everybody has a safe and happy and COVID-free holiday season. And we'll see you in January for other heat pumps. Good night, everybody.
Thank you all.
Thank you.
And just a note, as the rest of these people our attendees are signing off, please note that in the slide deck, there are incentives for your area. And if your area wasn't listed, you can go on to the Energy Smart Colorado website and see what is available to you. And you can always contact any of us that were on the contact slide. So thank you for attending, and we hope you have a great night. And as Mary said, a great holiday week.
Hey, Dave, this is
Thank
Sean.
you.
Thanks for letting me chime in there. Really great presentation. I'm looking forward to the recording and the slide deck to share with others.
Okay. Well, thanks for your help. Yeah.
Absolutely.
Well, and Sean, if you have any way to, any suggestions on how to improve it or anything, or new stuff coming down the pipeline with Mitsubishi or anything, because the next month is we're really trying to push it out to our consumers. So we're hoping.
Yeah, I was really impressed with the level of detail, and yet balancing that with, kind of middle of the road and generic, unbranded commentary. I think it's great. I think it raises a lot of boats really well. There was one slide that had a bunch of manufacturers on it and we weren't on it. I would ask for that.
Okay. I thought I had them all. How did
Dave.
Shoot, I'm sorry.
No harm, no foul.
No, I should. I thought I had you guys. Oh no, I have you. Oh, in the mini split, I have you in the next slide.
Yeah.
There you go.
For our panelists, I'm going to go ahead and stop the recording, and unless there's anything additional that you think is pertinent to this presentation, otherwise I'll go ahead and stop the recording, and then we can talk amongst ourselves.
Yeah,
That'd be
that's
good.
good.